Hello and welcome. Thanks for joining our webinar, Achieving Agile Web Security. My name is Laura Levy and I'll be hosting the event today. Today we'll discuss how accelerated release cycles that have become the new norm for DevOps teams have created direct conflict with the review, test, and monitor tactics of security practices. And we'll provide tips on how organizations can enable agile and secure software development and release. A few quick notes before we begin. Today's session will last about 40 minutes with ample time for Q&A at the end of the presentation. Please use the question field in the control panel of GoToWebinar to ask questions throughout the presentation, and we'll address as many as we can at the end of the event. Today's presentation will be recorded and will provide all attendees with a link to the recording and make it available on our website at www.trustednight.com. I'd like to introduce our presenter, Ted McKendall. With over 20 years of information security experience, Ted is a certified information systems security professional and has gained expertise in a variety of roles from security consultant to product manager. Ted is the mastermind behind many cloud-delivered payment industry security solutions used by millions of businesses today. Ted is currently the Vice President of Product Management for Trusted Night. With that, I'll turn it over to Ted to get us started.
Thanks, Laura. Hello, everyone. Good afternoon. Before we get started with the meat of the presentation today, I'd like to give you just a quick 2-minute background on Trusted Night to let you know who we are and where we came from, just for those of you who may not be as familiar with us. Trusted Night is a relatively small security company, but we've been around for a while, since around 2010. We were founded by our background, really, is in the intelligence community, and there are several of us on the team, myself included, with security product experience as well. So bringing together kind of that intelligence experience with security product experience is really kind of a foundation for the products that we deliver. Our focus is taking complex security challenges and providing lightweight, simple solutions that are very non-impactful for our customers and our users. We focus on 2 areas currently. One is endpoint security. Unlike most of the endpoint protection products on the market, we don't focus on that arms race between the bad guys and the defenses. We're not trying to block infections and look for signatures or indications of compromise and quarantine things and so forth. We essentially assume that the endpoint is compromised, and we effectively render the malware inoperable, or at least prevent it from performing its core function, which is to steal or exfiltrate data to be used for account takeover and financial fraud. And we do that in a very lightweight way that doesn't really interfere with user behavior on the endpoint or other security layers that may be in place. We take that same sort of mindset to web security with our Cloud-DMZ product, and providing the same kind of enterprise-grade security, but a very simple and easy-to-deploy interface. And we'll talk more about that later in today's session with today's topic. Today's topic is Agile Web Security. As Laura mentioned, we see a lot of conflict these days between organizations that have shifted their development culture to be one of continuous delivery, or DevOps, to enable the business to respond and adapt more quickly to market needs and dynamic forces, feedback from customers, competitive intelligence, etc. And the security measures that most organizations use today to defend web applications just can't keep up, and there's a lot of conflict there. So we'll start the session by going through some of these traditional security techniques that are used to defend web applications. We'll touch on the sort of themes of DevOps and continuous delivery, and then we'll show how when you bring those 2 things together, there is friction, there is conflict, and what some of the key challenges are in those areas. And then finally, we'll talk about Trusted Night's Cloud-DMZ product and how this can resolve those conflicts and actually enable a secure collaborative environment for continuous delivery. Let's first dive into conventional web security techniques. Web security today, web applications today are increasingly complex, as we all know. Not only are we dealing with the traditional sort of three-layered architecture, presentation layer, application layer, and database layer that's been around for a while, but there's an increasing number of components involved at each of these layers. Some of them are infrastructure related, some of them are service provided, some of them are homegrown, some of them are commercial products, some of them are open source. You have tools like content management systems also in the mix. And then you have a very distributed environment typically where these things are deployed. Sometimes some of the layers are deployed at cloud service providers or in multiple data centers that are distributed. Sometimes they are replicated across data centers and sometimes hosted at third parties and sometimes not. So you have this very heterogeneous mix of technologies and layers and components in modern web applications, and this just increases the complexity, and complexity, as we know, is the enemy of security. So it makes it very challenging to secure these applications. And the attacks themselves have gotten increasingly sophisticated, not just on the DDoS side, but also on attacks against the infrastructure and the products that are used, and as well as attacks against the actual business logic of your application. So there's this evolving sort of and innovative attacker crowd, very crafty folks, and there's the exceedingly complex web application environment that we're operating in. And put that together, security really is an important thing, and most organizations struggle with it. So let's look at some of the techniques that are in use today. I'll sort of broadly classify these in three different categories. The first is what I would call the best practices area. This is application security code reviews, penetration testing. I think any organization would agree in principle that security is important to build into your software development lifecycle. This includes the requirements, design, build, the test, the deployment, etc. So security should be involved in all aspects of software development. And then before any code reaches live users, it should undergo full security review as well as penetration tests to make sure that there are no vulnerabilities when looked at from an attacker's perspective, that there's no way to exploit it and get access to data or do things that shouldn't be done to the website. The challenges there are that all of this kind of security review and penetration testing requires specialized skills. Most organizations, except for the larger ones, don't have that expertise on staff, and they need to go to outsourced providers to provide that skills. That even for those organizations that do have those resources internally, they're in very high demand, and it's very difficult to schedule those resources for the projects that they're needed. And then the effort itself takes time. The business wants to get new features and new updates out to their users as quickly as possible. So adding a large security review at the end of a development cycle it does delay the time to market for pushing out new updates. If we look at technology solutions, in particular web app firewalls, I would generally classify this as two types of web app firewalls. One is what I'd call a blacklisting and signature-based WAF. These are the advantages of these are that they're typically very easy to use. Very often they're cloud-based services. To activate them, it's a matter of largely just creating some DNS rules to redirect web traffic through the WAF in the cloud before it gets to your own website. There's no infrastructure to deploy. It's just configuration changes. And there's not a lot of policies and configuration within the WAF itself that's typically required. because these products typically use one-size-fits-all types of security policies. They're looking for known attack strings or attack activity or known bad actors, such as known botnet endpoints. So they are sort of moderately effective at that sort of what we know about and what sort of that lowest common denominator type of attack. But anything sophisticated, certainly anything that's zero-day or anything that's specifically targeting your application or the business logic of your application, a cloud-based WAF is going to be really ineffective against. So you get simplicity, but you don't really get the depth of security that most applications need. At the other end of the spectrum, you have these what I would call a whitelist WAF, and these are full enterprise-grade solutions. Very often they're appliance-based, or you can get virtual appliances, virtual instances of some of these. But ultimately, what you're getting is a very rich and configurable and sophisticated enterprise-grade security product. It can be very effective if properly configured, but because of the complexity, it makes it a challenge to get these things properly configured. Manual configuration is often required, and there are specialized skills that are needed to do that kind of configuration. It's not something that developers or operations teams are usually equipped to do. There may be some automatic learning or configuration that's part of these products, but it's slow. It's not really effective. It doesn't really get you there, so you almost always need manual tuning anyway. And all this sort of configuration usually results in very large security policies. A typical website might have thousands of rules in their security policies enforced at the WAF. And that kind of complexity just inevitably leads to false positives, which are interfering with legitimate users who are trying to use the website. They're blocked because of some misconfiguration, or false negatives, which is arguably just as bad, letting attacks through. So these inevitably result. There's a lot of testing that needs to be in place with these kinds of solutions because they are so complex. As we look at DevOps, DevOps, for our purposes, is sort of a term I'll use to refer to this notion of continuous delivery, this notion of being able to, in a very agile way, deliver updates and new features to users. DevOps, for our purposes, is a culture within an organization that fosters collaboration and communication among the software development organization, the quality assurance team, and the IT operations team to enable and facilitate the very rapid, frequent, and reliable build of new features and delivery of new features. So in other words, it's a culture that allows the IT delivery organization to keep pace with the ever-changing needs of the business. For organizations that do kind of a DevOps culture or move towards a DevOps culture, there's some key themes that are important that they typically utilize. This is a simplified picture, but just to illustrate sort of a snapshot of what this might look like, they typically use agile development processes. This is contrary to the older sort of waterfall development technique, which basically is very lumpy. Let's take a whole bunch of time to write some requirements, hand it off to the development team, let them develop the entire project, and then hand it off to the testing team and let them test the entire project, etc. That approach leads to very sort of megalithic projects, very long-term projects, very difficult to course correct midstream and not very responsive to changing business needs. Agile development practices, contrarily, are very nimble and sprint-based. They iterate and evolve towards the requirements rather than try to address the entire thing at once. And you continually have code being pushed through the requirements, the development, the testing phase, and sometimes the deployment phase. Another key feature of this kind of DevOps culture is automation. Automation is what really enables the organization to work so efficiently and to the different groups involved to work together so well. Build automation, test automation is really important, especially when you're talking about regression testing, very complex applications. Automating as much of that as possible really streamlines the distribution process. And furthermore, deployment automation with complex applications and lots of components and code in multiple places, it can be very challenging to keep track of. So to be able to sort of plug together build, integration, testing, and deployment in a very streamlined fashion, even to the extent where only when certain subsets of the application are modified or updated, that little subset makes it through the pipeline without having to do major updates across the board for the entire application, can really streamline and improve time to market of delivery. So when we bring that mindset to security and try to combine the two, we find that security just really doesn't fit well in that picture. And the reason is because it's not even represented in the picture. If we go back to that diagram that's often shown for DevOps of pulling together development, QA, and operations, where is security? Now, some might argue, well, security is sort of pervasive. It should be everywhere. People should build it into every stage in the process. And that's true, and that may be sort of a security awareness that's built into the software development lifecycle. But where is the security team represented in this picture? Are they part of that collaborative initiative? How do they fit into the overall cultural change that happens here? And that's what I think is part of the problem. Here's a quote from Gene Kim, one of the thought leaders of DevOps, and he's basically saying that security traditionally is used to doing full security reviews in sort of this after the release is done sort of mode, and they don't know how to react when things are constantly in flux and code is moving very rapidly from build to test to deploy. When do they do their security review? When do they do their testing? If they try to, they end up getting in the way of the process and slowing things down. So if we look into what causes some of this, there's a few reasons. One is that fundamentally the delivery team and the security team have different goals. The delivery team is focused on meeting the business's timelines for getting new features to market, which can be very aggressive. They have objectives. The business needs things by certain dates, and they are very focused on streamlining their processes and automating their processes to deliver in that time frame. They may be responsible for secure development, but they are not responsible for security. So they may need to include secure requirements into their design and into their testing and into their deployment, but they're not responsible for the overall security of the application. They're hyper-focused on those deadlines. On the other hand, the security team is the complete opposite. They are very hyper-focused. Their whole mandate is to make sure that any released applications are secure with no critical vulnerabilities. And it's tough to reconcile that with time-to-market deadlines. When you try to institute those, security ends up suffering. And if you don't try to put deadlines on security, then it tends to very much extend how long it takes to deliver new features. There's also a culture gap fundamentally between the delivery team and security that's evolved. So a DevOps culture emphasizes collaboration and communication between different departments, cross-functional integration. Very often the tools that they use for automation at each step are follow-on or hooked into each other so that it's a very streamlined process and changes flow from one step to the next in the pipeline. Whereas security still is very much an island. It relies on specialized staff with specialized tools, and those tools are very disconnected from the rest of the delivery automation tools. They're not in any way hooked into them, and as I mentioned earlier, they often require manual configuration and manual skills to actually tune and configure and utilize. On top of that, there's sort of deeper differences. Security and DevOps just don't even speak the same language at most organizations. Security is, they're very focused on risk assessments and compliance regimes and threats and things like that, whereas DevOps and the rest of the delivery organization, they sort of maybe conceptually understand that, but they don't often know how to apply that or how to make that integrated into their processes and culture. If we take some of these differences and apply them to the techniques that we saw earlier for traditionally defending web applications, we can see how this conflict really manifests. So the first approach we talked about was using application security reviews and penetration testing. And here, I think, is one of the bigger challenges we see when trying to introduce security into a DevOps pipeline. The security person, sort of the traditional security person, loves the waterfall method because that means that everything is sort of done and through QA and finished and signed off, and then he gets to do his security review and penetration test. Security folks usually find it challenging to do a penetration test while code is still evolving and dev is still fixing bugs from QA. It's very challenging to integrate it into a dynamic environment because the security guy will say, hey, if anything changes, if you fix a bug, you might introduce some new security vulnerability that I need to discover in a pen test. So I need to wait till everything's done, and then I'm going to do my pen test. And the streamlined sort of agile release process that an organization may be using doesn't really ever finish. There's constant changes going through this pipeline. So the security team may say, well, all right, well, let me know when you sort of finished all those iterations, and then I'll do my test. And then it gets challenging just to schedule a security review because with an agile environment, every sprint they're sort of reevaluating what they should do next. So that end date might vary, and those pen testers, as I mentioned, are very difficult to schedule, especially if you're using external agencies for them. So how do you coordinate that? And then once you do coordinate that, let's say you get up past all that and you actually start your pen test. If it finds something, which most of them will, and those are critical vulnerabilities, you got to go all the way back to the development step so they can fix those, and then you've got to test them. So it adds this sort of big unknown to the end of your pipeline that says, I don't know when the security testing is going to be done, but it needs to be done. And it's just incompatible the way that it's been historically done with a streamlined delivery pipeline. If we look at the WAF options, we talked about two different classes of WAFs. The blacklisting and signature-oriented WAFs, actually, they're not necessarily in disagreement with DevOps. And that's largely because there's not a lot of configuration or management involved in them. They just sort of sit out there in the cloud, and if there's changes to the application, that's okay. It doesn't really involve the WAF. But that's exactly, honestly, the limitation of the WAF is that they are generally a one-size-fits-all policy, looking for just bad stuff. Doesn't necessarily try to understand the application or build rules that specifically protect that application. So from a security perspective, unless it's a really simple application that doesn't really have security concerns, then I don't think that these kinds of solutions are very effective. On the other hand, the whitelist WAFs, which can actually protect applications and do have the sophistication to have policies in place to secure web applications, suffer from some of the same challenges that the penetration testing and application security review does, which is that they require specialized skills. They typically are tacked on at the end of the process. And what you end up with is somebody, remember that these WAFs can have thousands of rules in their security policies. So somebody needs to manually tune those rules, or you need to switch the WAF back into that learning mode and hope that it sort of picks up the differences. Regardless, it's adding a lot of extra time onto the end of your development cycle, and it is very likely, again, to introduce false positives because of the complexity of the WAF. Putting all this together, we call this development drag. This is the notion that when you try to introduce security into the web application development process, it ends up delaying things no matter which technique you use. It's going to drag on the development process. Whatever the business needs and whatever the delivery team can actually deliver is going to be extended, sometimes substantially, because of the development, the security costs that happen afterwards. There's an example here from a financial service customer where the institution's marketing team wanted to deploy just a simple marketing sitelet. It wasn't really a major website. It was just an add-on little microsite attached to their main site. So they went and they sort of scoped out what it would take for them to design and build it, and they had certain timelines to make to get the information out there. There was a component of their website that involved a registration form. Users could register for webinar. And because of the bank's policies, that necessitated a security review and penetration test for this little sitelet. And when they went to the security team to get a scope for that, the response they got was that little piece would not only be challenging to schedule, but it would require several weeks of work just for that security review. And the marketing team looked at their calendar, looked at the schedule, and ultimately just decided to scrap that initiative because it wasn't worth their effort. Now that's an extreme example, but it shows you that there is a mentality that security is often a block business to deliver. I kind of boiled down and distilled the bullets from the previous slide and the previous discussion into a few key challenges here. So when you try to bring DevOps and security together, the goal is to reduce development drag, but still deliver a secure application to users. The first challenge is that security teams are responsible for securing 100% of the application. Now, security might be built into the development lifecycle, like we said, but ultimately it's the security team's scope to really consider the entire application and infrastructure. And 100% of that is really their responsibility. There's no reduction in scope. And as we saw earlier, these applications are incredibly complex, which contributes to the amount of time it takes a security team to do a review, to do a pen test, to configure the WAF rules, etc. And the complexity of those WAF rules also introduces delay. We talked about even using learning engines that are insufficient, the special skills that are required to configure WAF security policy rules, the fact that these could introduce false positives or false negatives and need retesting. This is all introducing additional delay into the process. And then the third thing is that security tools and the security team itself ultimately are disconnected from the rest of the delivery organization. They're still perceived as sort of a separate island. They may influence policies, and they may spread awareness, and they may guide secure development life cycles, but ultimately the tools that they use and the way that they perform their testing is disconnected typically from the rest of the delivery organization, and that adds delay and makes it difficult to foster that collaborative interdepartmental sort of sharing. All right, switching gears a little bit, let's talk about the Cloud-DMZ service that Trusted Night offers. The objective of Cloud-DMZ is to offer the kind of sophisticated enterprise-grade security we get with a whitelist WAF, with the simplicity and ease of use of a blacklist signature type WAF. The simplicity part is easy. It is a cloud-based service, so that means it's very easy for organizations to use the service. It's simply a matter of creating some DNS rules, redirecting web traffic through Cloud-DMZ before it gets to your website. So the simplicity starts pretty easy. There's not a lot of configuration that needs to happen. There are not thousands of WAF rules that need to be configured. The security part is where a lot of the core of the product is, and I'll talk about how we deliver that. At its core, Cloud-DMZ includes an active learning engine. The active learning engine is different than learning engines of a typical whitelist type WAF. Those learning tools that they have are very much focused on monitoring network traffic, monitoring behavior of users as they interact with the website, and trying to build out a security policy based on likelihood of users doing this or doing that. By contrast, the Cloud-DMZ active learning engine is just going straight to the application and inspecting the application itself. So it crawls the entire scope of your web application and maps it out, and additionally, it actually interacts with it as a user would. It pushes all the buttons, it analyzes all the forms to figure out which fields are optional, which ones are mandatory, where do errors get generated, and it builds this analysis of your web application. And it does two things with that analysis. One is it creates a secure cloud replica, and I'll talk about that in a minute. And the other is it builds out a security policy to enforce on the traffic that goes to your website. So let's look at a quick picture that illustrates the architecture here. In the middle, you've got sort of that dashed line of Cloud-DMZ and your websites at the bottom of the screen, customers' websites at the bottom of the screen. As I mentioned, the active learning engine is what's proactively reaching out and crawling the customer's website, analyzing it, and building this sort of analysis of it. The secure replica is the first output of that. Now, the secure replica is actually a replica snapshot of all static content from your website. So this includes the HTML pages, the JavaScript, the images, style sheets, everything on your site that is predictable static content is replicated into this snapshot in the cloud and delivered in this pre-generated secure replica. Trusted Night finds that for a typical application, 95 to 99% of the transactions that users can submit are served by static content, which means that the vast majority, 95 to 99%, of the content of your website can be offloaded to the secure replica, effectively reducing the attack surface of your website, because the only traffic that needs to go to your website is what we call dynamic content. These are requests for like a login or a user filling out a form, things that need to actually go to your backend database for validation or for logging. So that's dynamic content, and that's just a relative trickle of the overall traffic going to your website. And that traffic does pass through multiple layers of security policy. The first policy, and again, this is output from the active learning engine, is a complete whitelist of all of the valid URLs on your system. Because we've mapped out the entire scope of your web application, Cloud-DMZ knows exactly the complete universe of valid transactions that users can submit to interact with your website. So if anything falls outside that scope, falls outside that set, we turn it away. Either give them an error or send them to the home page, whatever you prefer. This takes care of the vast majority of sort of miscellaneous, spurious traffic that hits your website, whether it's botnet activity or people probing your website looking for admin pages or random crawls of different parts of your website, things like that. Those are all just disregarded, and they don't even go anywhere near your core website. They're blocked by that whitelist policy. This is a key difference between Cloud-DMZ and other cloud-based WAFs, because they typically are based on a reverse proxy technology, where if the service hasn't seen the URL before, it doesn't know if it's valid or not, so it passes it back to your website. If we haven't seen the URL before, we know it's not valid because we know all the URLs that are valid for your website. After the whitelist check, if it's dynamic traffic, it flows through additional dynamic security policies that look for things like form validation. And there's also a layer in there that where we use mod security for some additional signature-based blocking. But ultimately, there are several layers of security before that dynamic traffic hits your customer website. So how does this enable continuous delivery? Well, the active learning engine that's part of Cloud-DMZ doesn't just analyze the website once. It's recrawling and reanalyzing that website on a regular basis. So every time that active learning engine goes out to your website and crawls it, any new pages or content or images or changes that it sees, it incorporates into both the secure replica and the security policy that's maintained by the website as well. That's all automatic as part of the service. Many customers have that analysis happen on a time recurring basis, the same time each day or multiple times per day. Some of our customers even have that happen every 15 minutes, depending on the size of the website and the frequency of updates that we can work with you on and configuring the right frequency there. For organizations that really have a tight delivery pipeline, where you're actually only updating portions of, you're using automation to update portions of the application as it goes through the build, test, and deploy cycle, we can also configure Cloud-DMZ to just review at a very granular level the portion of your application that's been updated, and we can do that on demand. So it very much can align with a streamlined DevOps pipeline to compress that security phase of the rollout to almost be just automatic and a minor step in the deployment process. If we look back at the pulling together DevOps and security and the challenges we talked about before, we can see how Cloud-DMZ helps to provide application security at a minimal cost or no additional development drag. Initially, earlier on, we said that one of the challenges was that the security team is responsible for 100% of the application security. But with Cloud-DMZ, that secure cloud-based replica reduces the attack surface of the web application typically by 95 to 99%. So the vast majority of the content of that website is really locked and secure and doesn't really need to be inspected too closely by the security team. They can focus in any testing that they want to do specifically on the areas that deal with dynamic content, which, if you think about it, that's the most serious risk is, interactions with the database or somebody logging in or filling out a form. That's the most critical part of the application. We offload the entire rest of the attack surface to our secure replica, allowing a security team to just focus on those areas. Cloud-DMZ's infrastructure being cloud-based and being automated greatly simplifies the management of the solution. You don't have thousands of rules in a WAF policy. You have an automatically generated whitelist security policy and some other security policies that come out of the active learning engine. You get this improved security, the same kind of security you get from a whitelist WAF, but no false positives and no extended configuration time and management headaches. And finally, Cloud-DMZ helps bridge that collaborative gap between DevOps and security by automating the security updates and aligning them with the delivery pipeline. So again, if certain portions of the application change or you need to do it on demand because of a certain delivery schedule that you've got, Cloud-DMZ can fit right into that. So you can get improved control over the security updates, which provides more reliability in the timing and the time to market for new updates and features that you're delivering to your users and your customers. I would say, just as a last thought, I would say that it's very easy for you as a an organization to take a look at Cloud-DMZ and test it out. We do this all the time with folks. Give us a website. We can quickly set up a proof of concept for you. It doesn't really take any effort on your part. That's kind of the whole point. We'll help you with the analysis. We can do some scanning and so forth for you to show you the differences in the power that Cloud-DMZ provides and give you a chance to check out the solution yourself. At this point, I'll hand it back to Laura for any questions that have come in.
All right, great. Thanks, Ted. We do have a couple of questions that have come in throughout the presentation. Just a reminder to all of our attendees, you can ask questions now via the question function in the control panel of GoToWebinar. So Ted, first question, a couple questions here around this topic, so I'll try and summarize it up into one question. With all the security layers that traffic has to pass through with Cloud-DMZ, how does it affect performance of a web application?
Sure, good question. So we typically find, believe it or not, that performance overall is improved by the use of Cloud-DMZ. This happens, there's several reasons why this happens, but fundamentally, all of the static content being hosted in that pre-generated secure replica in the cloud, it's a very scalable infrastructure and very responsive, immediately responsive actually to customer needs. It can also be geographically distributed, so you can take advantage of the CDN capabilities that you can get in the cloud. So all static content typically has a 50 to 75% performance boost. Even the dynamic content, which has to pass through all those additional layers, tends to be faster because the customer's own website has much less activity going on. All that traffic is offloaded to the secure replica, 95 to 99% of it. So the only traffic that gets to the customer's website is dynamic content. So even though it's passing through additional layers, it ends up being processed and responded to much more rapidly. So even the dynamic content, we typically see performance improvements on that traffic. So I would say typically it's an improvement. At best, it's the same. Or at worst, I mean, it's the same.
Okay, great. The next question is, with Cloud-DMZ being a cloud-based tool, where and how can we do pre-production testing on our application?
Yeah, so we have several options for that. You certainly can use Cloud-DMZ even if your test environment is not accessible from the internet. And what we can do is we can restrict access. So we can set up Cloud-DMZ and have it work with your test environment. We can restrict access so that only your testers can access the Cloud-DMZ site if you really want to do kind of that end-to-end testing with the security in place. And then when you are ready to deploy, we can easily migrate over the replica and the security policy rules that were discovered during the testing to the production environment, so it's even more rapid. So we definitely fit into environments that want to test the security as part of their testing process.
Okay, great. I think that we are up against our ending time here, so we'll try to get to everyone's questions via email if we weren't able to ask it on the phone here. And a big thank you to everyone for joining us. As a reminder, we'll be sharing the recording of this session with all of you and on our website at www.trustednight.com. Thank you.